Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be current electricity. So this on the contrary to the previous video on static electricity where we talk about electrons being transferred but they don't move along much in the material, usually insulators. In this chapter we'll be talking about the movement of electrons in conductors and how they form currents like the current you see in the river. So I'm sure by now you have enjoyed the great benefits that electronic devices has given us. Things like your home appliances, handheld digital devices, they all work using electric currents. And so electric current, like the water current, is like the flowing of something. So what is it? It is the rate of the flow of electric charge. When you see the word rate, it's always about something over time. So in this case, it's current I equals to Q over T, where I stands for current, the unit is in amperes, Q is charges, is units in coulombs, and T, time taken, the unit will be in seconds. And rearranging it, usually what I was taught in my school would be Q is it. It's a lot easier to remember, so same, it's another formula yet again. So if you follow this channel for quite a while, you know that you need to do extraction, and then you plunk in the values, and then you equate. Long time ago, in the past, it was assumed that current flows from the positive terminal, and that means the electricity comes out from the plus side. However, as the understanding of physics developed over the years, we understand that actually electrons are the ones that flow from the negative terminal outwards. As such, we usually think about electric circuits in the conventional current, not so much of the flow of the electron currents. So unless asked by the question, you do not really have to consider the flow of the electrons from the negative terminal. You just have to think about the conventional electric current flowing straight out from the positive terminal. And how do we measure this is by connecting an ammeter. An ammeter measures amperes, so it's quite easy to remember, and you have to connect it in series. So imagine electric circuits just like any other river flowing. Okay, you have a generator, that like the battery that pushes the water around, and you want to measure the speed of this water. You have to place a water wheel along the river and then let the water wheel turn, and then you can see and gauge how fast the water wheel is turning. So the ammeter is playing the role of the water wheel. So we mentioned about the generator or the pump that pushes water. This, in the language of circuitry and physics, is called the electromotive force, EMF. So that is the power used to drive the charges for one full circuit. Okay, and that is in volt. The units is in volt. Okay, stating that the electromotive force of an electrical source is the work done in driving a unit charge around a complete circuit. And yet again, there's another formula. E, electromotive force of the electrical source, unit will be E equals to W over Q. E is EMF, electromotive force has a unit of volt, W work done, joules, and Q is charges, which is C. And usually, electromotive force will just put the unit as V, and you rearrange it equals to Q, V equals to W. And how I would remember this will be Queen Victoria is a woman, right? And just to take note that actually work done is also known as energy expended. So sometimes W can be changed to E. Okay, so just gotta be sharp and alert about the nuances of what the situation is asking you about and apply accordingly. So how do you arrange the cells, the batteries, whether in series or in parallel, also affect the total voltage of the circuit. So voltage, generally you have to think about it like a slide, a water slide. I'm sure you have played with water slides before in your life. So if you put two water slides in series, you're gonna get a total height twice the amount, right? And if you put the water slide in parallel, you're gonna get the same amount of height. Okay, so the voltage will be the same. So volt, you think about it like water slide, it is the height of the slide. And potential difference is something also very similar because you're also using the same units of voltage. Potential difference is the difference in potential. What potential? Electrical potential. Okay, that was not very helpful, but anyway, what it's talking about is the work done per charge in driving charges through the component. Okay, so what does it mean is you imagine same the water slide again, because this is in voltage. Imagine the water slide, so every component is like a little water slide. So what is the height of the slide? So the current goes past the component and slides down. Okay, that is the height. So if in one complete circuit there are many components, you have to add all these little slides, and that total amount of height will be the total voltage of the whole circuit. So same formula, V equals to W over Q. Rearrange, you get Queen Victoria equals a woman. So these are some differences between EMF and PD. Just know that EMF is the whole circuit and PD is talking about a particular component. And measuring volt is like, with all this talk about water slides, right? It's like measuring the height. So every component has their own, it's like their own little slide, and you connect the voltmeter in parallel because you want to find the top height of the slide and the bottom height of the slide, and let the voltmeter do its job for you to find the potential difference. Okay, next we talk about resistance. And resistance is like, since we are talking about currents, like river water, water slide. Okay, so resistance is like putting a stone in the river and it's kind of blocking the current from flowing properly. And that is pretty much very true in terms of the particles flowing, because in metallic bonding, so in where you learned in the earlier chemistry chapters, electrons are actually flowing through and past all the cations of the metal, and they pretty much bounce around and they have a lot of real resistance, and they go about by this formula: resistance equals to volt over current. Okay, is the ratio of the potential difference across the current flowing through it. And rearranging it, because I like to remember single row formulas, it's a lot easier. V equals to IR. This is what it stands for, and these are the units behind it. This funny looking symbol is called a ohm, 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 for unit for the resistance. And so in a circuit board, there are several kinds of resistors. There are the fixed resistors, where there's a fixed value, and this is communicated by the color bands on the resistors itself. And there's also a variable resistor, where it's made of a wire of high resistance and it's coiled around the tube, and there's a slider on top. So depending on how far you slide it, you are giving a larger or a smaller amount of resistance into the circuit. So it's like laying a very large stone slowly into the water, or you are just putting some standard rocks into the river. And resistance of objects go by yet another formula, R equals to rho L over A. Okay, and this symbol rho is not the same as the density one. Yes, it is actually pretty confusing and frustrating, right? All these things are, they have the same names. Okay, so what is this? Is the resistivity. The different materials, you think of it like different rivers. Different rivers flow and they have different kind of resistance because they are technically different materials, right? So they resist things differently, and that is a constant because the material doesn't change. And for this kind of concept, usually I teach students what you can imagine. You need to imagine yourself playing in the playground, walking on a balancing beam. The resistance equals rho L over A. L stands for length over A. A is for cross-sectional area. If the balancing beam is very thin, it's very difficult to walk, so it's high resistance, right? If the balancing beam is fatter, is thicker, then it's easier to walk, less resistance. If the balancing beam is very long, then yes, it's difficult to walk. If it's very short, then yes, it's easier to walk, less resistance. So that's about it. And so it works by a very simple ratio. If you twice the amount of length of this material, the wire, then the resistance is also twice, so on and so forth. Okay, so talking about length and cross-sectional area, right? These are a list of the common resistivities. It's just a constant, so don't have to commit them to memory. This is not too crucial. And just to note that materials with low resistivity are good for wires because current can flow easily. And those with high resistivity are good for heating, lighting elements, because the resistance is high, then heat or light is generated because current cannot flow easily. And with increasing temperature, the cations in the metals, they vibrate more vigorously. As such, electrons find it harder to move through. It's very true. Like if you imagine yourself walking through a shallow river and the rocks in it are starting to vibrate very vigorously, you will find it difficult to walk as compared to the rocks are staying still, right? So with higher temperature, resistance increases. And if you put a ratio on the current against volt and they turn out to be a straight line, they are said to be an ohmic conductor. And ohmic conductors are good for making wires just to connect components to components. And if it is not a straight line, it is bent, right? Then in this direction, usually it's good for making a filament for a lamp, because it's not a straight line, it's non-ohmic. Resistance change as temperature changes, the particles vibrate faster. It provides more resistance to the flow of electrons. And this causes the material to heat up very fast and gives off a glow. This is how the filament works. As you can see, with a small increase in current, there is a large increase in voltage. This gives rise to a large resistance. Or if it bends in the other way, then it is good for being a diode. And a diode only allows current to flow in one direction. So if you connect it in the other way around, it's not going to work. Okay, and that is all for the topic. Let's move on to some questions. The potential difference between the ends of a conductor is 12 volt. Okay, so based on this sentence already, you must imagine that, okay, maybe this slide is like 12 cm. Okay, how much energy is converted to other forms of energy when 100 coulombs flows through it? So you see, electrical energy is what work done, right? You can think of it as E or W. So you have Q over here, you have V over here. What formula can you use? Q V equals to W. And you sub everything in, you will get 1200 joules. Okay, circuit is used to find resistance of a coil of wire. How do you connect the voltmeter and the ammeter? So a voltmeter is a component that measures voltage. So measuring voltage is like measuring the height of a slide. You need to measure the top end, connect the top end and the bottom end. So translating onto a circuit is just the front of the component to the back of the component, which means to say it's just connected in parallel. Voltmeter must be connected in parallel. Ammeter is like the water wheel, you need to connect it in series. This is the image that is shown in the answer, and this will also equate to this. It's the same thing. Okay, so this is the answer. Wire X has resistance of 9 ohms. Okay, wire Y, same material as X but twice as long, diameter 3 times larger. Okay, so you need to use your knowledge of the formula. Resistance equals to rho L over A. Okay, twice as long, so you need to multiply by 2. Diameter is a length. Okay, diameter 3 times larger, so the area will be squared up, will be 9 times larger. So you have to divide by 9. So 9 times 2, 18. 18 divided by 9 will be 2. The answer will be 2 ohms. Voltage current readings are obtained for different electrical components, which readings are for 3 volt 0.06 ampere torch lamp. Okay, so this one is the tricky one. You need to find the one that has the largest resistance. Torch lamp is non-ohmic conductor, therefore resistance increases. So this will be the answer. Student has 6 cells, each of EMF 1.5 volt. How do you give a total of 6 volt? So 1.5, of course, you connect 4 of them in parallel, you're going to get 6. So what happens to the last one? So if you have 2 batteries that face each other, which means to say they are connected in the one of them with the wrong configuration, they are just going to cancel each other out. And that leaves the other 4 to work its magic. Okay? So this will be the way to do it. This pair of cells are the ones that will cancel each other out. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!